administration for public buildings, airports, and infrastructure development projects. Engineer Nihal started his career as a site engineer in State Engineer Corporation and subsequently joined Saudi Bin Laden Group, Public Buildings and Airport Division in 1988. Biagaman Free Trade Zone Infrastructure Development Project is one of the major projects he completed in Sri Lanka as resident agent. After 32 years of service in Bin Laden Group, he retired as a project director of Maldives International Airport Expansion Project in 2020 and continued to provide consultancy service to the few companies as an external consultant. Engineer Nihal has managed 3 international airports in Malaysia, UAE, Maldives, and several public buildings in Saudi Arabia, Malaysia, and Dubai as project manager and project director. These public buildings and airports have become landmark buildings to those countries now. Engineer Nihal is a specialist in directing and managing design and build turnkey projects in a certified. Ladies and gentlemen, our colleagues, giving you the floor, and we'll discuss the use of digital twin in construction to reduce carbon footprint. May we please welcome Engineer Nihal Premachandra. You are muted, sir.
Can you hear me now?
Perfect.
Yes, we can.
Yeah. Greetings from Sri Lanka. And of course, among the airports and the iconic buildings that I have got involved in design and construction, Kuala Lumpur International Airport is one of my favorite construction sites, and Putrajaya Mosque as well. Okay, let me continue my discussion on this. Of course, I'm trying to show you how you can use the digital twin in construction to reduce carbon footprint, and showing you the way how to transform the built environment toward the carbon neutrality. Right. Now, what is carbon footprint of a building? Carbon footprint comes from 2 primary sources. One, embodied carbon. That is, you see, when you manufacture any material, you will use fossil fuels, grid energy, and we are fabricating or transporting, again, you use such energy. So that will emit carbon. And the other source is operational carbon. Now, when you finish your building and you have to put lighting, cooling systems, heating, and maintenance, there again, you are burning fuel where you will emit carbon into the atmosphere. You are sort of disturbing our environment. Now, our professional responsibility is to reduce this particular emission. How a digital twin reduce the carbon footprint? You have a facility in digital twin to optimize your design. You try to use less embodied carbon materials. Use materials with less carbon emission in that material. And of course, you can connect the digital twin directly to the CNC machines and bending machines. Do your cutting and bending exactly, reducing the waste. You are reducing waste means, okay, you are reducing the carbon emission. And of course, this informed material selection is also very important. When you are selecting the materials, you choose low carbon materials. Now, there is a certification that all the manufacturers should obtain in their material production to ensure the low carbon footprint. You select such materials where they have EPD certification, right? And look at this. Now, if you look at a steel production, if you use the electric arc furnace to produce your steel, it emits 75% less carbon than that you produce from blast furnace. So you ask your manufacturer or the supplier to give you the mill certificate. If you look at the mill certificate, you will find whether it is EAF or blast furnace slag. So this type of measures as professionals we can take to reduce carbon footprint with the help of the digital twin. Now, it is important that you save the quantity of carbon emissions. You can use low E glass instead of normal glass. You can use electric arc furnace manufactured structural steel instead of blast furnace manufactured steel. And you can explain to your customer about energy saving in electrical bills, because when you use low E glass, your cost will go up, but it can be offset by the benefits that you are getting with low carbon emission. Now, explain the citizen responsibility to protect the environment by promoting material use with less carbon. That is your duty, because most of the clients, they don't understand this, what is this low carbon footprint at all. So you can always calculate carbon dioxide emission saving in kilograms carbon dioxide emission per square meter for alternative cladding and shading materials. That way you can prove what you are trying to do scientifically. Now, what is the net zero project? Net zero energy building is a building which produces a renewable energy source, energy on site or nearby the site, which is equivalent to the energy consumed by the building on its operations and maintenance. Now, when I was doing the Dubai Sports Complex, we did calculate at the design stage. It was a design and build contract according to the RIBA stage D contract conditions. We did the calculations. We found how much energy, we predicted how much energy is required to run this building. And based on that, we designed a photovoltaic system to generate clean energy to support this particular carbon zero or net zero energy building. Why you say net zero energy? Because when you, of course, when you use the renewable energy, certain kilowatt hours per year, it has an equivalent carbon emission. So really that you are saving that particular carbon emission if you are using renewable energy. So if that is equal to the energy that is required to operate the building, maintain the building, there you are, net zero energy building is there. Right, now net zero carbon building, again, the same thing. Operational and maintenance carbon emissions must be equal to the on-site renewable energy generation carbon emissions. When you use the renewable energy, you are saving certain carbon emissions that must be equal to the operational and maintenance carbon emission. This is where net zero carbon building comes. Right, now these are the techniques that you can use to do the calculations. Of course, architects are not that much fond of doing calculations, but I am different. I do a lot of calculations on that. And of course, this is very important. You must calculate the net zero performance index. Net zero performance index is total on-site renewable energy kilowatt hours per year divided by total annual energy consumption per year. If the net zero index is greater than 1, you are achieving net zero energy. If it is less than 1, of course, you are not achieving, but there is an offset gap. Now, for example, I am giving this calculation for the Dubai Sports Complex. Here, I have got these figures, and if you want to know how it was done, maybe you can contact the organizers, and I can send you a copy of that calculation as well. And of course, we did not make 100% net zero energy, but we achieved 87.5% net zero energy. That is by producing energy with renewable sources. Now, let me explain this to Kuala Lumpur International, this Maldives International Airport. This is the digital twin that we prepared for this particular airport. Of course, when we put the sun path, we saw a lot of problems with this particular model. And you can see visualization is the best way to communicate with others. So that is what that I'm trying to show you. Here I'm entering to the departure hall, and here you have the receptionist. And after that, you have the self-serving kiosks where you can take your boarding pass, or you can see the flight information display board, and then you go to this particular counters to hand over your baggage. So it is very nice visualization. But digital twin, not only that, it helps us to study the problems of this particular building as well, because the western elevation was facing a lot of heat through solar radiation. I'll show you how we managed to counter that, because by countering with this front facade, we cut the energy consumption by 240 kilowatts per day, and we saved 720 kilograms of carbon emission per day. How did I do that? Now, I'm not achieving 100% here, but I will show you how I did that. Now here, this is the issue. Now you can see this is the original design. This is the western front corridor that you can see. This corridor is 500-meter long. It is a western facing corridor. It's exposed to evening sun. So solar heat gain inside to the building. Now, if it is that, the thermal discomfort is there for the passengers, because these passengers should walk from departure hall to the arrival hall, and from arrival hall to the seaplane terminal. It's about 500 meters. It is really 500 meters, not about. And of course, when this building, when this facade was introduced, we were saving 720 kilograms of carbon emission per day. In fact, we proposed this particular facade not because of merely energy concern, because the president, His Excellency the President of Maldives, called me to his office and told me, Nihal, this elevation is not our culture. You are gone with European culture. I want to see Malaysian, Maldivian culture. Then I asked, Your Excellency, tell me what is your intention? What is your culture that you want to reflect? He said, I want to reflect ocean waves, because Maldives, you have all the sea around, plus white sandy beaches. So this is the wave, this is the white sandy beach, and our architect was very clever to convert ideas into the reality. Now, this is what we did, and by that, we improved the carbon neutrality, and we managed to reduce the carbon footprint. Now, lower internal heat, lower electricity, fewer carbon emissions. Now you can see here, now this is an image. This image that we produced from the digital twin. And this was done even before I start foundation piling work, because I knew what I'm going to construct. I can visualize. Now that way, in the planning and the design also, digital twin simulate terminal layout and operations in real time, so we can avoid this congestion and we can ensure the smooth operation. You can see the path for the flight to come and park also is defined well on the ground. Now you have a lot of ramp services, ramp equipment around the flight. So we have marked all the locations based on the space available in the space planning. So digital twin allow us to make efficient airports and saving energy, and that will reduce the carbon footprint. And in addition to that, as a future provision, we designed the roof to mount photovoltaic panels to harness the solar energy. And that is also going to sort of make this particular building carbon zero target. I'm trying to reach that. And there was another clever thing that we did. We did study the temperature of this sea water. We found from 25 kilometers away from the terminal at 5-meter depth, the water is having a temperature difference of 6 degrees centigrade. That difference of thermal energy is sufficient for us to run the whole cooling system. That I have done the calculation with my design team, and we have proposed. Of course, when they have money to implement that, I'm sure that they will implement. And again, that we are reaching toward the carbon zero target if we implement both these photovoltaic panels and the thermal energy extraction. So this is how things are happening in our part of the world. And of course, being a responsible professional, I should always take care of the environmental effect. So this is a big issue, and I make sure wherever I go, I have this intention and mentality. Now, of course, doing all this design work, everybody explained that you can put sort of sensors to monitor the density of occupation and all the temperature. But using artificial intelligence, of course, you can control the energy consumption again, and that is also towards reducing the carbon footprint. Now, let me show you this. This is Dubai Safari digital twin that we constructed in Dubai. And this digital twin was done by SketchUp, and the architect has designed that as concrete framing, A-framing structure. When it came to me, I said, boss, this will not work, and I want to convert that into a structural steel building. And of course, we took this as a design and build contract again. And having done that, what I did, this is the physical asset that we constructed. This is the digital twin that we started working on. Now, the advantage here is that steel has a very good quality by which that you can always have a higher strength to weight ratio than concrete. Now, here I use 145 metric tons of 8 millimeter thick S355 steel plates produced in EAF. That means electric arc furnace. Now there you are reducing the carbon emission by 75% when compared with the blast furnace steel. So as architects and engineers, we must always encourage our clients to understand this principle, because 75% carbon emission reduction is not a small thing, right? And then here you can see that I have done my installations of framing. So this framing is very light. I was using 8 millimeter thick plate. Now, if it is a box section and 8 millimeter thick plates, that will reduce the foundation load. So I'm using a lighter foundation than normal foundation. So I'm saving materials, I'm saving energy, I'm getting close to my net zero energy building targets. Now here, of course, I'm inspecting. I was the project manager on this project, but when I converted that to steel, everybody started talking that Bin Laden is going to make a lot of money from this change and all these things. So it went to the Bin Laden himself, the news. Then he told me, Nihal, make sure that you personally inspect this particular structural fabrication. You being a structural engineer, of course, I was working as a structural engineer before in the same company, so he knows my capabilities. Now I did all this structural supervision as well. And then here you can see these steel box sections have a different, all that can be fabricated off-site with precise control, less waste, and fewer on-site emissions. So you are reducing the emissions because prefabricated. And if I start making concrete frame, I would have constructed extensive formwork, shuttering, wet curing, contributing to more carbon and labor intensity. So that I prevented by using this steel, and this is the final product that we produced there. And of course, you can see that I'm standing here, my height is about 1.5 meters. You can see the size of this element is about 1.2 meters. Right, now this is how we try to get all our buildings close to the net zero level. Now this is Dubai Sports Complex. What you see here is the digital twin, and here it is the energy building. Now if you look at that, and of course if I go to the inside, this is the image. This is not actual construction. Before starting the construction, we visualize, okay, I'm going to construct this. And of course, this was constructed for holding the FINA World Championship on 2010, December 10. And the date of completion is fixed. So I must use this type of technology to make sure that I do things exactly right, because I cannot make mistakes here. Now, this really helped me to get it done. And here is the place where we use this particular photovoltaic panels on the energy building to sort of augment the net zero situation. Here, we achieved 87.5% net zero energy. Of course, there was a 12.5% additional offset. I tried to use all the external lighting also with photovoltaic panels Still, in my time, I couldn't do it. I don't know whether they have done it now. Now, here you can see the Dubai Sports Complex actual construction. Look at the image of actual construction and uh, design 3D model image. So most of them are same. And not only that, this model allows our construction people to understand what they are going to do and how they are going to do. Now, because it's an odd shape. So when you have an odd shape, it is very important that you have a digital twin like that so that you can communicate easily. And even the trusses that we constructed based on that particular concept, because 3D model allows us to get things fabricated directly according to the precise size, reducing the waste. So reducing the waste means, again, you are reducing the carbon footprint. Now here, this is the next image where when we developed the digital twin in Maldives International Airport, structural model was done by one structural engineer, MEP model was done by MEP engineer, and the architectural model was done by the architect. Now, even the passenger boarding bridges, the manufacturer, they have their own 3D model or the digital twin, and baggage handling system manufacturers, they have their own thing. So we put all together and see how it will integrate. Now then you will find clashes. Now, we use Navisworks clash detection software to find all these clashes also. These clashes will be sort of notified to us automatically by AI algorithms, giving a snapshot of where the clash is happening. So based on that, we can sit down with the architect, engineer, and other stakeholders to resolve this thing. Now, if you start resolving that on the construction stage, now I'm doing everything in virtually. Now, if you start doing it in construction phase, you will start breaking everything, wasting energy, wasting material, increasing the carbon footprint. So this is the way that you can utilize digital twin to your advantage. Now, in addition to that, when you are developing the digital twin, you must give the information to your modeler about the work breakdown structure. Everything what is in the construction, you should give the sequence of your construction. Now here I am showing you that the planning engineers have a nice thumb rule where they use breaking of, decomposition of the scope into the packages. Each package should be completed within 4 hours or maximum 40 hours. So that type of breaking down will help us to get the progress also monitored, because if you delay in completing your project, you will be sort of, again, spending a lot of energy and you are not helping to reduce the carbon footprint. Now I have done the plan installation as well as actual installation monitoring, and then I can see if I'm getting delayed, where it is, and all these things visually. So this is very important to use digital twin in such situation. So this is what the final product, and I hope that you understood the importance of the digital twins in reducing the carbon footprint. Thank you so much.